These are homework problems. Exercise 4.1, question 10. Find the stationary points on that curve y equals x e to the x. This is product rule because you've definitely got two functions in x. U is x, v is e to the x, and we've differentiated them there. There's our product rule, or you can do vu dash plus uv dash, either way. We've done our product rule there. I'm just going to take out the common factor and factorize. We get e to the x, x plus 1. It's good to do that because when you find your stationary points by putting y dashed equal to 0, if it's factorized, it's much easier to work out your stationary points. Then we go for stationary points, y dashed equals 0. In other words, e to the x, x plus 1 equals 0. So therefore we've got two scenarios, that e to the x is 0 or x plus 1 is 0. Now, e to the x is 0 has no solutions. What I normally do for this, I do a sketch of e to the x. Remember, e is just the number 2.71828, whatever it is. It's like drawing 3 to the power of x. It's got the same shape. It's an exponential curve. So e to the x, when x is 1, what's e to the x? Sorry, when x is 0, what's e to the x? When x is 1, y is, like e to the x is 2.7. The curve looks like this. That is the sketch of y equals e to the x. Now, do you think that that curve could ever equal 0? No. So you write no solution. And I show that no solution by sketching it. So for stationary points, e to the power of x times x plus 1 is 0. So we've got two scenarios. E to the x is 0 or x plus 1 is 0. The way that you show that this has no solution is to sketch it. Okay? And then this one, x is negative 1. So we've got no solution for that one, or x is negative 1. So we're thinking there's a stationary point when x is negative 1. Let's just work out when x is negative 1, what's y? Negative 1 times e to the negative 1, which is what? Negative 1 times 1 on e, which is negative 1 on e. So, girls, you've got a stationary point at negative 1 on e. Now, this sketch I've drawn here is not your curve. This is the sketch of e to the x only, to show that there's no solution there. Okay? So we've got a stationary point at negative 1, comma, negative 1 on e. So now, how do I determine the nature of the stationary point? You could do the little table, or you could differentiate again. See, I don't like using, I'm just going to put what y dashed is here. It's x e to the x plus e to the x. Now, I'd probably substitute. I don't think I'd differentiate a second time, but if you did decide to differentiate a second time, do you know what the derivative of x e to the x already is? It's up there. You've already differentiated it. So if you want to do the second derivative, fine. Only in this case, because you already know what the derivative of x e to the x is, it's there. It's already been done. If it hadn't already been done, I'd probably just do the substitution into the first derivative. Remember, first derivative is gradient. It gives you information about gradient, whereas second derivative gives you information about concavity. Yeah, I'm going to do it both ways. So I'm going to do it by differentiating again. We already know the derivative of x e to the x from up here is x e to the x plus e to the x. So I've got, it's x e to the x plus e to the x times 1, but I don't need that, plus, so that's differentiating that first bit. I've done that. That's the derivative of that. I can put the times 1. Plus, what's the derivative of e to the x? So, girls, how can I simplify that? So, this, yeah, I've got x e to the x plus 2 lots of e to the x. Now, I substitute x is what? Negative 1 into the second derivative will tell me if I've got a maximum, minimum, or an inflection. So substitute x is -1 into the second derivative. And I get -1 e to the -1. We okay with this? Plus 2e to the -1. You need to, don't go and put this in your calculator, please. Don't. You're doing extension maths, you should know how to write this out. E to the -1 is 1 on e, so I write -1 on e plus 2 on e. So it's, girls, I've got a common denominator. It's, yeah, -1 plus 2 on e. So it's 1 on e. Now, you tell me if that's like 1/3 approximately. Because remember, if you just keep thinking of e as 2.7 or something close to 3, tell me, is that positive 1 on e? Yeah, it is, which is greater than 0. Therefore, concave up. Therefore, you've got a minimum turning point at -1 on e. Now we have to sketch it. Now this is when you need to pull out your calculator and work out approximately where -1 on e is. So now you get your calculator out and you go -1 divided by e. Shift LN button to get e. And to do e, you've got to go e to the 1. Otherwise it doesn't do it for you. Can you all do that? It's -1 over e. Approximately -0.3637 will do. But you write it like this, but you put the approximation under here for your sketching purposes only. Do you know what I mean? But you must give the exact value. If you don't give an exact value, I'm telling you, you're going to lose a mark. You will lose a mark without an exact value. The only reason I wrote this down here is so that you know where to put this -1 on e. It's at approximately 0.3, about 0.4, 0.37. So what does our curve look like? Let's sketch. We've only got one turning point and we've got a minimum at -1, and the other -1's there. So, oh, this is a bit bad. I reckon it's about here. Yeah, we might have to see what else happens with this. I don't know what's even going to... All right, let's substitute. So we know we've got a minimum here like this, right? Why don't you substitute something like -5 and just see? Make sure it's up here or if it's down here. Into your original function. So we're trying to sketch y equals x e to the x. So if you put -5e to the -5, you'll get an idea whether it's an asymptote or whether it's up here. What do you get? So it's an asymptote. So girls, you might want to do, we can't do limits with these. So I've got x and y. When we did -5, just to give us an idea, we got negative or 0 point, it's small. We know when it's -1, you've got the minimum turning point. Can you see? Well, it must because it's a minimum turning point. It's a minimum. So this is -1, -1 on e. You don't write it as -1, -0.37. You write it as -1, -e, but this lets you work out, you know what, you don't even need to do this -1 on e. You should say it's -1 on 3 approximately. It's about -1/3. You don't even need to put the e in. Like if you're trying to sketch it approximately, it's approximately -1/3. Now, what about when x is 0? What do you get?
0.
Yep. So, geez. There. Goes through 0. So, girls, I might draw this again. This is pretty bad. So, you've got a minimum. I need to do it bigger, and I'll make the scale a lot bigger. And I've only got about 10 tapey things on my desk. I do. I've got 10 of them. All right, I'm just sketch. You need to indicate main points. I might go back up to this one now because I've made such a mess of the other. So showing a point I've done when x is 1, y is 1 e to the 1, which is e. We also know that when x is 0, y is 0, so show that it goes through the origin. We've got the minimum. So I'd write minimum at -1, -1 on E, and show here that you've got an asymptote. Okay, show that you've got an asymptote there. As x approaches -infinity, how do you write that? As x approaches -infinity, y approaches what? 0 from above or below? So you go 0 with a little minus showing it. Yeah, so isn't it good that we're doing this? So as x approaches -infinity, y approaches 0 from below, you put a little minus. That's your asymptote. Because I decided to, I wasn't sure, I knew I had a minimum here, but then I didn't know what happened after that. So we just picked a big value of a negative x value like -5, and we got -0.03 as our answer. So you should always check and see what happens to the curve, okay? Yeah, tricky one, that one. Just looking here for your inflections, second derivative equal to 0, factorising out the e to the x, x plus 2. We know from before that e to the x equals 0 has no solution. The other solution is x is -2. When x is -2, you can work out the y value. So therefore, we've got a possible inflection at -2, -2 on e squared. Checking concavity change around the point -2. You get negative, 0, positive. Therefore, concavity changes. Therefore, you have an inflection. We've got an inflection at -2, -2 on e squared. Now that means a change in concavity. That's what an inflection is. So when you come to do your diagram, you've got minimum, see, concave up, now it's concave down. That's what an inflection is, a concavity change. That's why the curve goes like that, and then you substitute your x is -5 or whatever you want to try, and you'll see that when x is -5, y was -0.03 or whatever it was. Does it make sense? It gives you the shape.